Okay, so now we're looking at part 12, which is other stoichiometric conversions. So basically the equations can indicate the number of particles and volumes of gases at STP in a reaction, but in the problems we're going to have to convert to moles, and then we can use a bunch of these conversion factors you've seen earlier to convert to other units. So the helpful conversion factors that we have right here, these are a bunch of them we might want to use. Okay, so we've got the Avogadro's number. We also have that 1 mole is the molar mass, and we also have that a mole of gas occupies 22.4 liters at STP. So this first problem here, how many liters of hydrogen gas are produced when 40 grams of water are used in the reaction? So first thing we always want to do with these equations here is A, write a reaction if we don't have one, but B, if we have one, make sure it's balanced. So if we look here, we've got 2 oxygens here, but only 1 on this side, so that means I'm going to need a 2 in front of here. That means I double the number of hydrogens, which puts a 2 there as well. Now that it's balanced, I can go ahead and start the problem. So I'm going to use the number we're given in the problem, which is this 40 grams here. So we're going to have the 40 grams to start us off here. And remember that here we're really going to want to keep the units. So this is 40 grams of water. The water part's going to be really important there. Alright, so now we're going to start making a conversion bridge using dimensional analysis, which we've done a little bit earlier. So grams of water, since it goes here, remember whatever unit's here comes down. So we've got grams of water here. And that's going to be the number of grams in 1 mole. Ignore that there, H2O. Okay, now in order to find the number of grams, we would look at the periodic table, add up 2 hydrogens plus 1 oxygen. So that's going to give us a total of 18 grams. Okay. After that, we need to convert into liters of hydrogen gas. So we're not there yet. Right now we have moles of water. These 2 would cancel again. Alright, so we're going to keep going. So what we have up here has to come down. So we've got moles of water. And here's the step, that new step that we're going to use to get from one thing to another. It's the mole ratio step. We're going to get from moles of water to moles of hydrogen, then ultimately to liters. To figure out what numbers go here, we're going to go ahead and look at the reaction. There's a 2 here and a 2 here. So there's going to be a 2 and a 2. Then the last step, we're going to, again, whatever we see up top comes down. So we got 1 mole of hydrogen here and 22.4 liters of hydrogen. These will cancel, so will these. Alright, so these cancel, we're left with liters of hydrogen, which is good, that's what we want. When you go ahead and calculate that, you should get around 49.78, and this would be liters of hydrogen. Okay, and that's all for that problem.